I'm the Senior Astronomy Education Specialist here at the Astro Society. The Astro Society was founded in 1889 as the Astronomical Society of the Pacific. We're an international nonprofit organization that is about science and education and working to increase the understanding and appreciation of astronomy. We've been enjoying a wonderful first day of our Astronomy at 250 conference and are very excited to present this evening our special free general public event, the celebration on life and the legacy of Nancy Grace Roman. We have a panel of brilliant women who are going to be speaking about Dr. Roman, but first we have a few brief announcements. I'm going to turn it over to Chanel.
Okay, welcome everyone. Tonight we're delighted to have this conversation about Dr. Nancy Grace Roman celebrating her life and legacy, a very influential astronomer who blazed a pathway for many folks that follow. What we're showing here is Stream Alive. It is an add-on tool to Zoom. Many of you, of course, are familiar with Zoom after COVID. And one of the things that came up, of course, is how do you do active learning? How do you encourage conversations? How do you encourage discussions rather than lecturing, which we know doesn't work? And Stream Alive is one of the ways we found in our Learn at ASP workshops. One of my colleagues will drop the link in the chat to our offerings. We have several workshops that are open to the public, the science-attentive public, to formal educators, K-12, gen ed college faculty, and of course, informal educators, those at planetariums, museums, libraries, etc., national parks, and amateur astronomers, astronomy enthusiasts, those who are members of astronomy clubs throughout the country are another big constituency. And so delighted to have you. We've got 92, 93 respondents. And so let me jump to our next question to kind of set the stage. Before tonight, oh, sorry, apologies for the typo. Before tonight, how familiar were you with Nancy Grace Roman's story? And so in this case, you can see there's 4 numbers on the left, 1, 2, 3, 4. And just as you see your compadres doing, just enter it in the chat. And this dynamically updates. And it's a great way for the panel and our host to get a sense of who's in the audience and what they come in with, right? Unlike a clicker question, for those that use clicker questions, you want a flat distribution because it's chaos, right? You don't want 80% saying yes because that's a bad question. What's the point of teaching? So this is good. This is good. Just give it another moment for you to register your thought. Okay, please. What single quality do you think allows one scientist to change what becomes possible for generations after them? So in this case, we're not entering numbers. You're going to type in a word, a phrase, and it will populate. So these are these word clouds. And of course, the size of the word scales is related to how many people are saying it. So you can see curiosity is much bigger. That means several folks have entered that. And this is a great way to kind of visualize, again, the diversity of ideas, the diversity of attributes that scientists generally share, but in this case, it's leading us to talking about Nancy Grace Roman. I have one more piece, and that's a short video. But before I go to that, were there other announcements, Teresa?
I believe we were thinking about talking about Learn at ASP. That is our learning platform. We will maybe talk about that at the end. Let's get started. I'm really excited. We're going to show a short video about Nancy Grace Roman, talking directly from her own words and her own mouth. So Chanel's going to show that. And I love seeing these words pop up.
It's hard to decide how history will view my accomplishments. People generally aren't terribly interested in what gets things started. And so I'm not sure they're going to have much of an idea of my role.
Nancy Grace Roman served as the first chief of astronomy in NASA's Office of Space Science, the first woman to hold an executive position within the agency. She was instrumental in the early planning of NASA's first great space observatory, the Hubble Space Telescope, earning her the nickname the Mother of Hubble. To honor her, NASA has given her name to one of its most powerful upcoming space observatories. WFIRST, the Wide Field Infrared Survey Telescope, is now the Nancy Grace Roman Space Telescope. Nancy Grace was born in 1925 and developed an interest in astronomy at an early age.
I just was fascinated. Between fifth and sixth grade, I organized my friends into an astronomy club to study the constellations. I certainly did not receive any encouragement. I was told from the beginning that women could not be scientists.
Nancy Grace persevered and graduated from the University of Chicago in 1949 with a doctorate in astronomy, despite continuing to encounter discrimination.
My thesis professor, there was a period in which he went for 6 months without speaking to me, even when I said hello to him in the hall. He didn't want to have anything to do with me.
After several years of research, NASA came calling.
I started in NASA in 1959. I was 6 months old. Being the first executive woman at NASA turned out not to be terribly eventful. I was accepted very readily as a scientist in my job.
During her 21 years at NASA, Dr. Roman was involved in the development and launch of many space-based observatories, which studied the sun, deep space, and the Earth's atmosphere. Her most enduring legacy at NASA was the planning of Hubble and its science program. She did much of the early advocacy and established the program's structure, which laid the foundation for other large NASA missions that followed, and helped convince the astronomical community to support astronomy from space. After retiring from NASA, Dr. Roman stayed involved in the space community and received numerous awards for her pioneering work. Over her career, she inspired generations of young astronomers. Now, with the Nancy Grace Roman Space Telescope, her legacy can continue to inspire generations more.
Thank you for sharing that movie.
It's hard to decide how history will.
So we wanted to give you a little taste of Nancy Grace Roman as a woman and the start of this evening. But I also want to introduce our moderator, France Córdova. She is currently the president of the Science Philanthropy Alliance, which she's an internationally recognized astrophysicist with more than 3 decades of leadership across universities, national labs, government, the former NSF director, and the only woman to serve as the president of Purdue University. She's a fantastic moderator for our evening. So I'm going to turn it over to France. Thank you so much.
Great. Thanks so much, Teresa, and thanks, Chanel. This is a great opening to our conversation. First, let me ask, can you hear me all right?
Yes, loud and clear.
Great, good. Well, I'd like to add my welcome to this conversation about the life and legacy of Nancy Grace Roman. This is the public opening event of astronomy at 250, the 138th annual meeting of the Astronomical Society of the Pacific. That's a lot of meetings. The 3-day meeting will commemorate 250 years of astronomy in the US. So as Teresa said, I'm France Córdova. I currently lead an alliance of 50 foundations whose mission is to advance science through visionary philanthropy. And that's a mission that Nancy Grace Roman, herself a philanthropist for science, as you'll hear, would have loved. Among my past positions is chief scientist for NASA. Today, I also head the Space Studies Board, which, among other things, will oversee the next decadal surveys for astronomy, Earth and planetary missions. So in a few days, fingers crossed, NASA will launch the Nancy Grace Roman satellite, whose aims are to address dark matter and dark energy, uncover many more exoplanets, and do wide field surveys. That's an ambitious agenda. Its field of view is 100 times larger than that of the Hubble Space Telescope. It will be a space partner to Hubble and the James Webb Telescope, as well as the Vera Rubin ground-based observatory. So we ask how rare it is for NASA to have named a satellite for a woman who was on the agency staff. Who is this remarkable person? What were her goals, her achievements? What can we learn from knowing more about her? Can we connect with her passion for science? Can her actions motivate our own? These are subjects that we're going to address in our conversation. We're going to hear from 4 distinguished women about different aspects of Nancy Grace Roman's career. And then we'll turn to you, our audience, for your questions. So this will be a very participatory thing. We'll save our questions after the last of the 4 speakers has had a chance to inform us, because all of their talks are connected and we want to get the full complement of the background of this remarkable woman. So first up is Dr. Rachael Beaton, who will talk about the satellite and the science. Dr. Beaton is an astronomer with the Nancy Grace Roman Space Telescope team at the Space Telescope Science Institute. She received the 2016 Robert C. Trumpler Award for her doctoral dissertation and has held fellowship roles at Princeton and the Carnegie Institution for Science. So Dr. Beaton, what is the Roman Space Telescope? What will it do?
Just unmute yourself, Rachel.
Okay, I think I'm unmuted.
Yes.
Okay, awesome. So I am here. I'm actually on my way to the launch at Cape Canaveral. We stopped overnight here in Columbia, South Carolina. So I've been in the car all day. And I'm going to talk to you about the Roman Space Telescope and what the mission's going to do. I work at the Science Operations Center for the Roman Space Telescope, which is at the Space Telescope Science Institute in Baltimore. Continue to share. In Baltimore, and we also operate the Hubble Space Telescope and the James Webb Space Telescope. Most of what I'm going to show you is in this Roman press kit, which is available online. So if you have your cell phone while you're watching the live stream, you can click that and get more information about the mission, including lots of links and how to follow along for the next couple exciting months. I'm also a board member of the Astro Society. So Roman is a space telescope that is launching 9 months early. The mission was really conceived of and put together in 2010, and to be launching in 2026, only 16 years later, is pretty remarkable for NASA missions of this size and scale. Also remember, we had that global pandemic in there, which set things back a little bit while the facilities weren't accessible. So on the far left of your screen, you're seeing a picture of the fully built satellite in the high bay at the Goddard Space Flight Center in Greenbelt, Maryland. And you have 2 people in what we call bunny suits, because all of this is in a giant clean room, who are standing in front of the telescope to give you a sense of scale. The telescope itself is actually about the same size as the Hubble Space Telescope in terms of the actual structure. It's actually a donated structure. It used to be a space satellite. It used to be a spy satellite. It was actually donated and shared around the facilities, the government agencies, and then retrofitted to become the Nancy Grace Roman Space Telescope. The mirror is actually a mirror, the Hubble spare. So if everyone remembers, the Hubble Space Telescope was actually launched in the early 90s, and that mirror had some problems. But this spare mirror was actually okay, and also was repolished and refinished with the most modern technology that we have today. So we're recycling and reusing equipment, but we're also spending a lot of money on updated technology, including a high gain antenna, and I'll explain why we need that. And I'll talk a little bit about the primary instrument on the telescope as well. The picture here in the middle is actually the telescope being taken to the port of Baltimore. It turned out that the telescope plane, so a military plane that can put a telescope inside of it, was unavailable. And so they actually shipped it on a boat. And to ship it on a boat, they actually put it on a vehicle and drove it through Baltimore in the middle of the night on a relatively undisclosed route, which is actually the most terrifying part about this whole launch experience, was that drive through Baltimore, in my opinion. Then it went on a boat and went all the way to Cape Canaveral. And the picture on the far right is actually the truck pushing it into the bay where it would be integrated with a SpaceX Falcon Heavy for launch in almost exactly 2.5 days. So the launch is Sunday, August 30th at 7:26 a.m. And we're very excited about that. Oops. Where we spared no expense was building the wide field instrument. So up in the upper right, you'll see a picture of the instrument itself with a bunch of people who put it together to give you a sense of size. This is a huge instrument, and it's a 300 megapixel camera. Now, there are bigger cameras like the LSST on the Rubin Observatory, but very importantly, we're launching this to L2, so 1.2 kilometers away. So this is one of the biggest cameras and most sensitive cameras that we've ever constructed as astronomers. The detectors are shown in the lower left, and you can see a person there again for scale in their hand. So you can see how big this focal plane array, how big the camera actually is. The middle image here is our filter wheel, and the mechanism that sits in the center that actually turns these filter wheels so that we can take pictures in different types of light. That mechanism is about the size of a bicycle tire. It's huge. And then on the far right, we have a picture of one of our test engineers who's comparing the cell phone camera on the back of your cell phone, a typical type of camera or chip that we're familiar with one of our 18 sensors for the Roman Space Telescope, which is about the size of a saltine cracker. So this is a huge instrument and unique, completely custom built to do what Roman wants to do. Roman will launch hopefully on Sunday, and then it's actually going to travel about 1.2 million miles to the Lagrange point 2. When it's there, it's going to be joining the James Webb Space Telescope, the Gaia satellite, and the Euclid satellite. They're all on very different orbits and will occasionally take pictures of each other. But the reason we're going to L2 is that the Roman science needs stability. At L2, you are away from the Earth, and the telescope will cool and be very stable so that we can have incredibly sharp and precise images. The Hubble Space Telescope, which is only about 300 miles above the Earth, circles the Earth, and that means that about half of the time it's between the Earth and the Sun, and we can't use it for astronomy. In contrast, the Roman Space Telescope will be able to use most of its time to do astronomy and won't be heated by the sun every 90 minutes. And before I show you what Roman was really designed to do, I'm going to give you a quote from Nancy Grace Roman, who's pictured here. She was immortalized as a Lego, and there's some interviews with her about how being immortalized as one of the Lego women of science was really how most people got to know about her. We'll talk about it later, but she was the mother of the Hubble Space Telescope, so her little Lego set comes with a small space telescope. But she is quoted as saying that the real way to look at the night sky is to look at it. And what Roman is going to allow us to do is to look at the night sky in a way that we never have before. So I'm going to play this movie here and I will talk over it so you have a sense for what's going on. But we're starting with a ground-based image of the Pillars of Creation, which is inside of the Carina Nebula. And I'm going to start the movie. So we're looking from the ground. Now we're going to sharpen and go to space. You see how much sharper everything is at the Hubble Space Telescope. And this is a very famous image from the Hubble Space Telescope. And as we're zooming out, we're going to get a sense for the field of view, the instantaneous field of view of the Roman Space Telescope. And so this is what we get every time we take a snapshot with the camera. We actually are getting a field of view about 100 times larger than the instrument that captured the original picture. And we get that every time we take a picture. Roman doesn't just have this massive field of view. It's optimized to cover huge areas of the sky very quickly. And because of that optimization, because it's not orbiting the Earth, it can actually cover areas of sky that would take 1,000 times faster than HST. So 1,000 times faster we can pass across the night sky. Okay. So I know a lot of people here are amateur astronomers and probably spend a lot more time looking up than I do as a professional astronomer. But on the sky, you're going to see a composite of the Galax UV image of Andromeda, which shows it so beautifully, and also the full moon to get a sense of the full moon to Andromeda on the sky, if you could see it with your eyes. And on the left, you're actually going to see the image of the footprint of the field of view. So those 18 detectors here, it covers about half of the Andromeda galaxy in one picture. Now, this area has been covered by Hubble. It took what do astronomers? It took about 1,000 orbits, and we can do what they did in about one snapshot. And there's the moon for scale. The field of view is 0.28 square degrees, which is about the size of the full moon on the sky. And so we can map the sky incredibly quickly. So one beautiful quote from Nancy, she said, "When NASA was formed, one of the men there asked me if I knew anyone who would like to set up a program in space astronomy, and I decided that the idea of influencing astronomy for 50 years was just more than I could resist, and so I took the job." So Nancy really invented the concept of doing astronomy in space. There's some amazing writings about the initial ideas, like putting an astronaut up who would change the film behind the telescope, having a telescope wing of an International Space Station, all sorts of things. But it was really her leadership and the development of the technology that led to the Hubble Space Telescope long after she had retired. She retired just after that telescope was greenlit. And I really think what we're able to do with the Roman Space Telescope is getting to the mission that she had, which was to make large astronomical data sets available to the public. So this is a plot of the night sky, the whole night sky, so not just the north or the south. And you see the galaxy crossing the night sky, the Milky Way galaxy. And I believe this is an optical image. So Roman actually works in the near infrared. But what is mapped on the sky are the areas that we're going to cover with the Roman Space Telescope. And this blue area is about 2,000 this big blue area is about 2,000 square degrees. That's about the size of Ursa Major on the night sky. And we're going to cover significantly more than that. But we're talking about constellation-sized imaging at HST-like resolution. This wide area survey will be used to explore the properties of dark matter and the distribution of dark matter by looking for tiny changes in the shapes of galaxies over large areas. The blue dots that you'll see, or sorry, the red dots that you see here, here in the Southern Hemisphere and the Northern Hemisphere are a high latitude time domain survey. We'll be taking snapshots for periods of the 5-year prime mission. We'll be taking snapshots every 5 days to discover supernovae. And the objective there is actually these supernovae will be sufficiently far away that we'll be able to look at the transition from the matter-dominated universe and the dark energy-dominated universe to constrain what dark energy might be. The other thing that you'll see is in the center of the galaxy, there's a little orange splotch. That is the galactic bulge time domain survey. We'll be taking an image of these fields that are zoomed in here. These fields, an image will be taken roughly every 12 minutes for 6-month stretches at a time. And that is to monitor for signs of planets around near stars. And the signatures we're looking for are actually caused by general relativity. It's called microlensing, and the planets are being lensed by mass in front of them. And that gives us a brief instant in which we can see and measure a lot of the properties of that planet. And the planets that we'll be able to measure are not able to be studied in any other way. And so this will transform our understanding of planets like Jupiter and Neptune that are so far away from their parent star that other methods can't detect them. We'll also learn a lot about stars and variable phenomena in the galactic center. The yellow box here is our last survey, which is the galactic plane survey. We're covering from about plus or minus 40 degrees on either side of the galactic center, and we're also covering a huge part of the galactic bulge. Some of these weird extensions are to make sure we get the full extent of star-forming regions. Again, we'll be doing this at HST-like resolution of all of this area, and will be just transformative in understanding young stellar objects, the clustering of star-forming regions, as well as detecting lots of exotic phenomena. So that's what we're going to do in our first 5 years. And that explains about 75% of that time in 5 years. All of this data will be exquisitely calibrated, and there's no proprietary period. As soon as we get the data at Space Telescope, we release it to the public, and anyone on the planet can use it. And we are processing that data to a state where we believe people can use it with very little barrier between them and doing the science. But there are some challenges. So over here on this graphic is the Hubble Space Telescope. So Hubble sends us about 2.7 gigabytes every day. That is a quantity of data that I think we all are kind of familiar with. That's like a big movie. The James Webb Space Telescope sends us about 58 gigabytes every day, but the Roman Space Telescope will be sending us about 1,375 gigabytes every day. That's why we need a high gain antenna to actually send that data through. And that's one of our biggest technological accomplishments, is the ability to send that much data from L2. That's transferring an equivalent of 1 million songs through Spotify, streaming 1 million songs from the L2 point, from 1.2 million miles away. There's no proprietary period. The data is available as soon as possible, so we do have to process it. It comes down in these compressed formats, and they have to be put back together. And then we process it from the raw data from the camera. That's what my team does at Space Telescope, all the way through to the best calibrated data that's ready for science. We are not using the deep sky network that all other spacecraft use. We actually have our own network to handle these data volumes. It's 3 telescopes that give us nearly continuous view downlink capabilities from the telescope. And instead of putting our data in an archive where you go with your laptop and you pull down the data you need, we're actually putting the data in the cloud. Almost all of our operations are actually in the cloud. And we built what's called a server-side platform, which means you open up your web browser, you log in to something called the Roman Research Nexus, and you basically open up what's called a Jupyter Notebook or a coding environment, and you access the data there. And all the compute resources and the data storage resources within reason are paid for by NASA for any user. And you don't have to be a professional scientist. You can log in as long as you know a little bit of Python. There are tutorials there to teach you how to use the data, and anyone can do that. You can log in now, just Google Roman Research Nexus and follow the instructions on our website. But really, to look at the big picture of what Roman's revealing, we anticipate 80,000 supernova, thousands of microlensing exoplanets. We really don't know exactly how many, because we really don't know how many Neptunes there are out there. We'll be getting the properties of over 100 billion stars, billions of galaxies, hundreds of black holes, hundreds of forming planetary systems, so young stellar objects in star-forming regions, 100,000 transiting exoplanets, so the ones we detect by changes in the light of the parent star. And that's all coming at an inflow rate of 1.4 terabytes of data every day that the teams at Space Telescope and at the Infrared Processing and Analysis Center will be putting together and then serving on a server-side platform that anyone can use to access the data. All of this sounds amazing. And the really important thing to say is that people are actually what make these dreams happen. So this mission was probably inconceivable when Nancy Grace Roman started, because of all the different technology that just did not exist. The detectors didn't exist, high gain antennas didn't exist, the technology to send things to L2 didn't exist. And this is highlighting the profiles of the Roman team at Goddard Space Flight Center. Again, I put a QR code here. If you're teaching students, inspiring students, there's just beautiful profiles of all of these beautiful people on the Roman team. There are people that manage the process, that buy the equipment, that get it there, that keep things on schedule. There's people that do the engineering to make the spacecraft work, that do the technology testing and development. The communications team, almost all of the graphics I've shown you are from the communications team. There's amazing stuff on the website, games to play and to learn. And then what will get the most visibility over the next couple of months and years will ultimately be the science that's coming from the science team. And I think it's really important to recognize that the science teams are everyone, it's the entire community. And that it takes all these people with a lot of different skill sets and perspectives to make things like this happen. So there's a square here for you or for your students or for anyone who might want a career at NASA. These are all people that work at Goddard Space Flight Center. There's an entire different team that works at Space Telescope in all of these different areas. And it's really a labor of extreme dedication to bringing something like this to life. The equipment that were put together in the spacecraft come from facilities in 10 different states and have been shipped all over the country. And at my institute alone, there's about 400 people that actually work on the Roman mission, which is doing all the data handling and scheduling of the telescope. So it's no small endeavor, and there's lots of space for lots of people and careers to participate. And the last bit, because I want to leave a little bit inspirational, is something that Nancy said, which is my career was quite unusual. So my main advice to someone interested in a career similar to my own is to remain open to change and new opportunities. I like to tell the students that the jobs I took after my PhD were not in existence only a few years before. And so it's very important to recognize that the path that you might take might not even exist when you set out. So that's all I have about the Roman mission. We'll take a lot of questions. I saw a lot going on in the chat. At NASA, we actually use Teams and WebEx. So when things are popping up at me, I'm not sure what's going on. But Roman is ready, set, to go. And here, if you take a screenshot or a bunch of the links, they're also all in the press kit so that you can follow along. And there's beautiful data, visualizations, pictures of the telescope, everything that you could possibly need. Can be found on all these public websites because this is a mission funded by the public and we put as much as we can out there for everyone to enjoy. Thank you.
Well, thank you, Rachael. That was just amazing, fascinating, and really comprehensive. And it's great to see you end with that quote and to see the teams and the diversity of the teams. It's just amazing. So thank you. And as you said, there are lots of questions and there's lots of comments, and some people are answering other people's questions. So that's great too. Next, we're going to hear from Dr. Linda Shore about Nancy Grace Roman's bequest to astronomy education. Dr. Shore is Senior Advisor and former CEO of the Astronomical Society of the Pacific. Before that, for over 20 years, she was Director and Senior Scientist of the Exploratorium's Teacher Institute. And in 2023, she received the AAS Education Prize. Dr. Shore.
Thank you. This is a really exciting opportunity for me to tell you what Nancy Grace Roman means to me through my lens as a 67-year-old retired person who started in astronomy at a time where only a handful of women would go to the conferences that I attended. So one can imagine what it was like for Nancy, who was born in 1925, 5 years, someone pointed out 5 years after women were given suffrage, the right to vote. A very different world. So let me share my slides here. First thing you're going to see is that. So can you see my slides or are you seeing the presenter view?
No, it looks great, Linda.
It looks great. Okay, fabulous. So I titled this talk Astronomy for All because when you look at Nancy Grace Roman's philanthropy, when you look at the things she cared about, what she deeply cared about was having astronomy be democratic, that it was for everyone to participate in. It was for everyone to have a career in. And we already looked at this slide from when she was a child, and what she talks about, and what resonated also with me, was that between 5th and 6th grade, she had already become so interested in sky watching that she wanted her friends to be just as excited about it. So she would gather up her girlfriends, mainly her girlfriends, and at night they would go out and lie down and watch the sky, watch the stars, and she would teach them about the constellations. This was something that resonated with me because I also was interested in the stars when I was a little kid. And once I learned all the constellations, I wanted to tell all my girlfriends. And I think for many of us at this conference, we became astronomy communicators, educators, because of our passion that we had as a child. And then we wanted to share that with other children, other grown-ups, other people. And this was also true of her. And by 7th grade, she says that's when she decided she was going to be an astronomer, even though she knew that this was going to be a tough road for a woman to go down. She was going to try for it. And this is a quote of hers. Now, this was also still true of me in the 1960s and 70s as a kid. Most of my teachers and later even my high school instructors and college instructors were not terribly encouraging. So as she said, I was told by many people that a woman could not be an astronomer. I'm glad I ignored them. One thing she talks about is a counselor who said to her, now, why would a young lady want to be an astronomer and take astronomy? They should be studying Latin. Same thing was said to me. I should be sticking to history and English and not spending so much time in mathematics and science. So things have changed. Things are better for women today, but as she herself pointed out later in her life, they're not perfect. We still have a long way to go. As women in this field, we stand on her shoulders, but people will also be standing on our shoulders, right? And going further than we went. One thing she did during her career was reach out to women because she recognized how difficult it had been for herself. And she wanted to make sure that other women were encouraged and that she could be a role model. This comes from Smith College. And she would often, this is an example of her going to Smith College and showing a group of young women her work at NASA. And she said, one of the reasons I like working with schools is to try to convince women that they can be scientists and that science can in fact be fun. Well, she passed in 2018, and in her very generous bequest, there were only 2 organizations that she recognized. One was the American Association of University Women, where she gave them a list of things that she would like them to do, one of which is to make sure that not only women are encouraged to go into the sciences, but women of color and other marginalized groups in the field. The bulk of her bequest went to her. There was only one other organization that she gave a sizable bequest to, and that was the Astronomical Society of the Pacific. And that's something that I am immensely proud of as the CEO at the time. And I was the first woman executive director of the ASP in its 130 some odd year history at the time. So I was very pleased about that. And so I want to tell you what it was about the Astronomical Society that resonated with her. And I think you'll see. The vision of the society for a long time, since its founding almost in 1889, is that people of all ages and backgrounds can understand astronomy, and here's the second part, and have the ability and desire to share that passion with other people. That's our vision. And our core value, which I believe also resonated with her, as you could tell, was astronomy is a democratic science available to all people, regardless of their age, gender, backgrounds, ethnicity, economic status, or abilities. So those two, our vision and value resonated with her. And so she had always been a supporter of the organization. She always generously gave annually to make sure that we could continue our education outreach. And we would send her care packages. Our office manager, Pablo Nelson, was particularly eager to send her Christmas packages from us. And so one of the Christmas packages contained all these materials from a brand new project we had, where we wanted to encourage preschool children to engage in astronomy at their abilities, at their level. So, if you're going to count, why not count stars? If we wrote a storybook about observing the moon, they were able to draw the moon as best they could in, a pan of salt with their fingers. They could finger paint the shapes of the moon. So they're learning the skills of science, observation, very basic skills, but through the lens of astronomy. And this was an NSF-funded project that was very successful, and she was very eager to get all the materials that we would send her in a box so she could take a look. Another project of ours that she was particularly interested in, again, because of her interest in supporting women and girls, is we had a project where we partnered with the SETI Institute to create astronomy badges, NASA astronomy badges. And these Girl Scouts would engage in astronomy activities. And then when they finished doing their project, they would get a badge with a NASA meatball on it, which is very exciting for a kid. And again, we would send Nancy a box of materials telling her all about what we had done. And one of the things that she was very interested in this project is we not only worked with the girls, and Teresa Summer, who you met, it was integral to this piece of the project in particular, but we wanted to help Girl Scout leaders and amateur astronomers who were involved in the project to communicate with children, particularly girls, in ways that were encouraging. Because sometimes it's very easy for us to communicate with young people in ways that are discouraging. Like, for example, oh, don't touch that, you'll hurt yourself. Or let me do that for you. Or, yeah, you've heard those things, right? So we wanted to improve how astronomy educators communicate. And you can see the difference is, how do you communicate with children in a way that develops a growth mindset, meaning I can do this. I'm going to embrace mistakes. Mistakes are okay. That's how I learn. I'm going to keep going. I'm going to be persistent like Nancy, right? Versus a fixed mindset where, oh, that's too hard for me. I don't think I can do it. Math is too difficult. We want to have people be more like the people on the left and the right. And so we, Teresa in particular, did a number of workshops where we helped people communicate more effectively with children. And lastly, I want to talk about this, the Great American Eclipse of 2017. We all remember it. We at the Astro Society wanted to make sure that not only were people engaged on the path of totality, but we didn't want to forget those people who can't travel to the path of totality because of financial constraints, because they work. There are lots of reasons why people cannot be in the path of totality, and that eclipse is just as awe-inspiring in many ways. Sure, totality is wonderful, but if you have a pair of eclipse glasses and you watch, right, the moon cover the sun, that can be just as exciting. And again, we developed kits for amateur astronomers, for teachers, for museums. We distributed more glasses than I can possibly remember. And we sent her a kit. We sent her materials. Well, at that time in her life, she lived in an assisted living facility. And she wrote to us and said, not wrote to us, she called and said, help. I want to make sure that everybody in my assisted living facility can enjoy this eclipse. So can you please quickly send me as many eclipse glasses as you can possibly scrounge? And we did. We managed to pull together a whole packet. And I showed, this is not actually from her assisted living facility, but something that I now do now that I'm retired is I work with seniors. And I think about Nancy all the time. And she actually inspired me to teach senior citizens online. I teach courses in astronomy for the Lifelong Learning Institute at a local university, where about 80 to 100 seniors from home, because some of them aren't mobile, learn about astronomy. And next month, I'm going to be doing a 4-week course on Nancy Grace Roman and the Hubble and the Nancy Grace Roman telescope in her honor. I also do some work locally with seniors. And so personally, I want to thank Nancy for her influence in my life as an educator. I want to thank her for her incredibly generous and transformative support of the Astronomical Society and the American Association of University Women. And I want to encourage all of us to think of standing on her shoulders, not only in science, but in encouraging young people of all ages and all backgrounds to engage in astronomy. And thank you so much.
Thank you, Linda. That's very inspiring. So we'll turn now to Dr. Meg Urry, herself a pioneer for women doing science. Meg will place the context of Dr. Roman's life in a larger picture, bringing science, passion, and personality together. Dr. Urry is a professor of physics and astronomy at Yale University. Her own focus is on massive black holes and their effect on the evolution of galaxies. She has served as president of the American Astronomical Society, as chair of the Department of Physics at Yale, and as part of the Hubble Space Telescope Institute faculty. Meg, please give us the historical picture of women in astronomy.
Thank you, France, and everyone. And good evening to everybody. I know some of you who are watching, and I look forward to hearing from everyone. Can you hear me okay? And can you see my slides okay?
Yes, everything
Right.
looks great.
Thanks. So the Nancy Grace Roman Space Telescope, as people have said, is the first NASA mission to be named in honor of a woman scientist. This is an entirely fitting way to recognize Dr. Roman's role in creating a space science program at the beginning of NASA. When I was first starting out in physics, I didn't think too much about the lack of women in my classes or on the faculty, or if I did, I guess I assumed that they just hadn't been interested in physics. I know that was dumb. I was just excited about being maybe the first woman this or the first woman that, but eventually I wised up and I realized there'd been lots of women doing physics and astrophysics, despite the lack of encouragement and sometimes the outright discouragement they might have faced. Women simply weren't promoted and celebrated the way that their male counterparts were, and consequently they weren't as numerous or as visible. And smaller populations, we should say, like people of color, gender minorities, religious minorities, people with disabilities, et cetera, have also been underrepresented and poorly supported or outright discriminated against. So Nancy Grace Roman, who got her, let me see if I can advance this, who got her PhD in 1949 from the University of Chicago, was decades before the first U.S. woman astronaut went into space. That was Sally Ride in 1983, or before the first woman was appointed to the Supreme Court. That was Sandra Day O'Connor in 1981, or before there were more than a handful of women in Congress, or before there were women leaders in business, or women presenting the news on television, or presidents of universities, or women in visible leadership in positions of almost any kind. There were, to put it simply, very few role models for smart, ambitious young women in her day. She was aware of the odds being against her, but as Linda said, she didn't let this slow her down for a minute. She had wanted to be an astronomer since childhood, so that's what she was going to do. She reminds me of some of the other early astrophysics pioneers, Mariah Mitchell, Adelaide Ames, Cecilia Payne-Gaposchkin, Margaret Burbidge, Vera Rubin, who had to move forward in the face of outright opposition. And don't forget the famous Harvard computers, as they were called, women who were analyzing data and doing science at the Harvard College Observatory. Many of you know the story that Edward Pickering, the director of the observatory, figured out that he could hire twice as many women as he could men because he only had to pay them half as much. And so this is how many of these women got into science. Wilhelmina Fleming was Pickering's housekeeper, and indicated to him she'd rather do astronomy than clean his house. So that's how she ended up doing science. Annie Jump Cannon, the famous spectroscopist, and there were many more. Henrietta Leavitt, who wasn't in this picture, but was also a Harvard computer, she discovered the famous period luminosity relation in Cepheid variable stars, which was a critical step in understanding the distances to other galaxies. What I would call a major discovery, and certainly as deserving of recognition as Hubble's distance redshift relation. In a more enlightened age, we might have been talking about the famous Leavitt Space Telescope rather than the Hubble Space Telescope. Quite a few women astronomers were very important to me when I was starting out. And I just put some of my favorite people here. You may recognize at least one of them who is in front of you now. 50 years ago, when I was in college, my mostly male professors and classmates told me that discrimination was a thing of the past. We had laws now, they said, and people were enlightened, so no bias at all. 50 years later, young women today are still being told this same thing, even though experiments show that there continues to be ongoing bias against women in science. I joined the Space Telescope Science Institute in 1987 as a postdoc, and then joined the staff in 1990. And before that, I was a graduate student across the street at Johns Hopkins University, where my advisor had written the proposal that brought the Institute to Baltimore. So I saw the whole history from when the first 2 employees showed up in 1981 to when there were hundreds of staff 20 years later when I left for Yale. Of the first 60 tenure track astronomers hired at Space Telescope Science Institute, only one was a woman, Netta Bakal. And this is despite the fact that women earned 12 to 15% of PhDs in astronomy during the preceding decade. So that there should have been at least 7 women, and there was only one. This is just one example of how women were overlooked and underestimated. Ann Kinney was the second woman hired onto the tenure track scientific staff. She's the redhead in the upper right of this montage. And I was the third woman hired. We thought that still wasn't enough. So we spoke to the director, Ricardo Giacconi, about this, and he helped push to hire more women. We hired Melissa McGrath, Steffi Baum, Laura Danley, Anuradha Karatkar, and more as time went on. Although I will note that most of us were white women. In 1992, Ricardo and others helped us put together the first conference ever on women in astronomy. This is the conference photo. I'm in it, Ricardo's in it, quite a few people you might recognize are in it. One guy's in it who didn't come to the conference, but just horned in on the photo. Anyway, I won't tell you who it is. This was followed by a second meeting in 2003 in Pasadena, California, at which we also explored the dearth of people of color in astronomy. And then there was a 2009 meeting in College Park, Maryland, where we were welcomed to the White House by Tina Chen, who was the chief of staff to Michelle Obama and executive director of the White House Council on Women and Girls. Inclusive Astronomy followed in Nashville in 2015, and the fourth Women in Astronomy meeting happened in Austin, Texas in 2017. In 2017, we also began coordinating with other professional societies, and I would say the world of astronomy has really been at the forefront of working toward equity for the entire time that I have been aware of the professional societies, with codes of conduct, anti-harassment policies, meeting protocols, and other innovative ways to support everyone, regardless of identity. Now, going back to Nancy Grace Roman, and here's a picture of her at the 2009 College Park meeting. She's in the middle with Ann Kinney at the left, Vera Rubin, Kelly Cahoy, and Randy Ludwig. Nancy Grace Roman did not seem to need role models, but most of us do. And I did, even though at the time I was starting out, I probably wouldn't have thought I did. So I want to say to young women who are out there now, or to those of you who are advising or mentoring young women, women who are interested in astronomy and space science, today's world is much more welcoming than what Nancy Grace Roman experienced, even if the playing field is not yet quite level. But the opportunities are out there, and you can find people to support and mentor you. There are lots of role models now, and there's less discrimination. But I also want to say you may encounter discouragement at times. And if that happens, I hope you realize that this may be in part because you're not being propelled forward as vigorously as some of your peers, your male peers are. If that happens, please don't let it stop you. Think of Nancy Grace Roman and of the other pioneering women who persevered because it was what they wanted, who didn't let themselves get sidelined. I am so grateful to those women. We all, as Linda said, we all stand on their shoulders. And in 3 days, when the new space telescope is launched and it goes to L2, it'll take more than a few days to get to L2. As it travels to L2, I hope you will tuck away in your pocket Nancy Grace Roman's name and keep it there as a secret source of energy and pride that can inspire you in your journey to do the science that you want to do. Thank you.
Well, thank you, Meg. That's wonderful and very inspiring. Our final panelist is Jessica Harris, who'll talk about Nancy Grace Roman's mentorship of women in science and how that is powerfully transforming science itself. Ms. Harris is an astrophysicist, science communicator, and owner and founder of Jessica A. Harris, LLC. She's an award-winning mentor known as Auntie Jess to the students she mentors. She brings more than 15 years of experience in STEM education and public outreach, including employment at Space Telescope Science Institute and director of the Space Astronomy Summer Program. Ms. Harris, you're engaged with the next generation of astronomers. What is your mission and what are you learning?
Good evening, everyone. I know you asked me a question. I just want to say special thanks for the Astro Society for inviting me here. This conference is one of the few that I attend that I feel seen and valued as an educator, informal and formal, and just an outreach specialist. So shouts out to Astro Society for having me here. So my mission is to make sure that students that are underrepresented in this field have the tools to not only survive in our field, but also thrive. And so making sure that my students have the tools that Meg was just talking about. There's a lot that we're going to experience when she said about pay and just the way you may be treated. There's a high likelihood, I put it in the chat, that if you're underrepresented, you probably will be treated like that. And so I want to give my colleagues and my students just those tools of how to prepare for that. What was the second question? Oh, the asking about what do I hear from the students? So I do have slides. Let me share them briefly with y'all. It's on the last slide. Sorry about that. Okay, way back. Sorry, y'all seen that in reverse. My bad. So Meg has talked about the first conference for women in astronomy at Baltimore. I did work at Space Telescope Science Institute starting in 2010. I actually came as an intern with the summer program, which years later I ended up being the director of the program. So just want to say, like, the connection to Space Telescope there. Of course, I wasn't here and a part of that, but just wanted to mention that. So then in 2015, there was an inclusive astronomy conference, which was huge. It was a major deal. I was not here, but I just wanted to share like these monumental things that have happened for women in our field, and specifically in the inclusive astronomy, not just women, but all of those that are underrepresented. So there's a lot of recommendations that came out of IA1, and then we had IA2 events in 2019, which I was a part of. I'm somewhere here. It was a very sunny day. So I want to give a little context to the work that I have done. I'm going to continue to talk about my lived experience. And as I tell you about my lived experience, I want to share that a lot of what I'm sharing is also what my students have experienced. Okay, so when you're thinking about that, even though I am almost 15 plus years in this field, students that are undergrad and graduate that I reach out to, that I talk to, that I mentor, they're experiencing the same thing. So I wanted to share a brief story about IA2, not to be controversial, but there was some controversy that hit social media. Things were blowing up about attending this conference because of the selection process. I won't go into that, but there was a lot of feelings about that. I spoke up, as I often do, because I know I've been gifted with speaking up for those that often are not able to. I'm willing to speak up and take the shots, because often when I'm speaking up, I know that it's resonating with other people. So it was before a break, I mentioned that there were people who had mixed reviews for being selected and being here because of the backlash and what was happening on social media. And I told several people who came up to me, yes, put this on your resume. This is a big deal. There's only been two. There was one in 2015 and one in 2019. This is a big deal that you're a part of this. Yes, share that. And people shouldn't have to feel that way because of what's happening. So that's a change in what I'm hearing with our students. The impact of social media there's the good and the bad. I do a workshop, the good, the bad, and the indifferent of social media. And that's not something we had even when I was coming up. I was part of Facebook, not to age myself, but I was a part of Facebook when you were writing on people's walls at the very beginning, when it just was college students. And so that's some of the experience. But when I spoke up, there was immediate attack of what I was saying. And I'll never forget, we came back off a break and a senior scientist stood up and spoke up and advocated for me and supported me. And she made a strong statement that she couldn't move on with the meeting for herself if she didn't speak up. And so throughout my presentation, I'm going to share of what my students are saying. And I also want to give recommendations because that's how I am. I want people to walk away with practical things to do. That scientist standing up for me, even though I said it, I didn't mince words on what I was saying. I knew I was speaking for more than just myself in the room. But that senior scientist speaking up made a huge difference. And so if you are in a senior role, even if you're a mid role, even if you are early career, there is some power and there is some privilege that you have. And it doesn't take a whole lot to speak up. It doesn't take a whole lot to be brave and say the right thing or support someone else that's saying the right thing. All right, so at Space Telescope, I was a part of the Vision Reading Group, as we were called. This was a brand new program, and I was actually co-chair of this program. And we were instrumental. So anyone at Space Telescope can verify this for me, Rachel, please. I've heard it. I don't know if it's still true, but I've heard it from some people that are my friends that are still there. But this code of conduct that we put out of discussions and having meetings is something that was also used at the IA2 conference. But this is all something that also is something that's in every meeting room within Space Telescope. So we did another one, maybe not exactly this, but how to set up a meeting, how to have a safe space. That was a huge part of something that I contributed. So I'm not saying this to get accolades or anything. I'm just sharing that as we're in this field, sometimes women, sometimes those that are underrepresented don't get the credit. Because if you're at an institution, right, it makes sense. Space Telescope gets the credit for that. But we need to give credit. We need to give nods to people that are doing the work. So when I talk about my mission, my company focuses on consulting in DEI. I know that's a bad word, but it's what I do. Mentoring and outreach. And so for me, when I talk about diversity, when I talk about inclusion, when Dr. Shore was talking about every scientist being in the room and what that should look like, to me, it's a great statement of where we should be, but it's not where we're at. And so just wanting to challenge those, that there's a burden on some of us that are speaking up that others don't have. I was also a part of the workshop that we did at the Women in Astronomy. So that's why I was mentioning the Women in Astronomy that we contributed. And another example of how we can use our influence is my dear friend Lindell. I know she hates that I'm shouting her out right now, but she was accepted to present at AI2. And because of the work I was doing with her at NRAO, she wanted me to be along. For her, she was like, I'm later in my career. I'm going to retire in a couple of years. This is a huge opportunity for you. So I also want you to be a part of this. She yielded her privilege for me. I am grateful for the people in my life that have yielded their privilege to give me an open door. She couldn't have to do that. She wanted to give me visibility. I also want to share that at Space Telescope, my main role was to do outreach related to James Webb Space Telescope. So JWST will always have a special place in my heart. This position was not created. So we were talking about Nancy, how she went into a lot of different roles where it didn't exist. This role didn't exist until I came. I literally applied for another job, didn't get it. And they were like, we were so impressed by you. We're going to create something new. So I want to encourage the students that are on here and my Auntie Jess, as I always have to give a shout out to my students, that continue to do the thing that you love, continue to do it with passion, and don't let people tell you no. And if they tell you no and you feel discouraged, find people that will advocate for you. So I wanted to say, as my role at Space Telescope, I'll jump forward. This was the first cohort that I was a part of. And I want to say something specific about this. So of the 26 years of this summer student program, it was mainly white male dominated. I know we're scientists. We're probably not surprised by that, right? That's probably what we think. So I came on board and I wanted to change this program because, again, I was a part of this program. I remember being in the basement. I remember being the only one that was Black in the room. And I remember how that felt. And actually, all of my career, I'm often the only Black woman that is in the room. And so I wanted to make a change. I wanted to just, y'all shoot me, but I just wanted, I whisper this because it's so controversial, but it shouldn't have been. I just wanted equity as far as gender related to male and female. We put offers equally out to male, female. When final things and people declined and it came off the waiting list, guess what? It ended up being more female than male. That's a great thing, right? Let's give a shout out for that. That was like history in the making. Amazing. But let me tell you something. Me doing that to give an opportunity for students that otherwise wouldn't have that got attacked. It's not even mentioned. But someone came to the institute and said, well, if my son applied, he wouldn't have got it. He probably wouldn't have because he's a white male. And no, like it's not just like, I'm not saying every white male has a whole lot of privilege. I understand that, but I'm just saying like this was attacked. I left Space Telescope and I still had to provide data and information of how I created a process that is still, the review process for this is still being used to this day, right? So I just want to share that like part of the work that I've done and how it's impacted others and to my mentees and what I hear is that sometimes it's the work that people don't see, but it has lasting impact. I can't get credit moving forward, but I always wanted to leave the places that I was better than when I came. And I saw a video, let me go back to that. I saw a video where Nancy was talking about where in your early career did you face challenges as a woman? And I forget the role that she was in, but someone had mentioned that there was a woman previous to her that they said she was the useless. And so they were suspicious of any other woman working because the other one that they had before felt useless. And I just want to relate to my experience and my students' experience. We are often feeling this burden. We're the only Black person at this internship. We're the only Black person at this job. And we feel this huge responsibility to get it right, to be smarter, to work harder, to show up, to dress a certain way. So that is still happening. Okay, I'm about to wrap this up. So I know we're scientists and we love data. So I'll just share my own data. Okay, so I went to Grambling State University. It is HBCU. Whoop, whoop. And the year that I graduated, it was one person. I was the only physics student to graduate from our physics department, even at an HBCU. But collectively, of the bachelor degrees that were received from African Americans that same year, it was 2.9%. And I always share with people that I never needed this statistic to tell me how few women there were. Besides being at the National Society of Black Physicists, everywhere else I went, I was one of the few, one of the only. Okay, so fast forward to last year, the data is more or less the same. I think it's 4.7. The thing is blocking it. 4.7. So we went from 9.2. How many years later? It's only 4.7 has increased. So I gotta say this. People may not like me saying this. It's not an offense of anyone. But when we talk about how things have gotten better for people, it's gotten better for white women, not necessarily those that are underrepresented. There's still work to do, and we have to be brave and speak up. So if y'all are thinking of more, and then master's degree, I graduated with my master's in 2010. Of that percentage of people who graduated physics masters, it was 2% in the whole country. 2%. I was amongst those people, very rare. Shout out to my thesis advisor, Dr. Bob Odell. I'm super grateful that you're on this call tonight. So leaving you with some practical tools. You're wondering like what to do, what am I saying, how to help support students. The AIP team up report, it's done it. They've said it. How we need to encourage the factors that cause African Americans to fail or succeed is belonging. I know I felt that. That's why I wanted to make a change in the summer student program in every institution that I was at to create that sense of belonging. Because I consciously made a decision to not continue with the master's degree, and it took me years to feel like I belonged within our field. Relates to that physics identity. I am a scientist. I published a paper. I've done the research. I did the courses. I did astronomy courses in graduate school, never taking even an intro to astronomy before, right? So that scientific identity we help students with. Academic support. I will fast forward. There's another program that does provide financial support for students, personal support. So when we talk about all these things that we're experiencing, you need someone that's going to advocate for you. So I wanted to mention briefly about at Space Telescope. Just the dynamic, it's the way that it is. Like you're not a PhD scientist, you're not doing the science. They feel a way about people who have masters, and I was in the EPO department. Whoop-de-doo, right? But I knew what I was working against, and I created an advisory board for myself. So there was a two male scientists that we met. They would ask me all these questions. They would ask me why I did certain things. We would talk it out. And then when we were in a meeting, I knew, even though I was the director of the program, even though I had the information, even though I've done the research, even though I've done all the things and thought of all the scenarios, I knew they would hear it better from them. And so I allowed them to be an advocate for me. So I'm saying that the same for students. What I'm experiencing from students is that they often don't have those advocates. They're often stuck doing research with someone that doesn't want to work with them. Where do they go? They had to transfer their whole lives. They had to move from one state to another state. That is a common story. Something else that my students are experiencing is they are burning out at bachelor's degree, mainly if they're at a PWI, predominantly white institution. They're burning out. So when we talk about leadership structures, it comes from the top down. As much as the work that I did, we were creating policies, we were creating procedures, it's all from the bottom up. It has to be from the top down. That's how we make change. So that's why I'm talking to those people that are at the top. If you are at the top, use your power to make a difference. I wanted to share the national mentoring community with the American APS, and they have a program for mentoring with students. You pair as a mentor, you pair with a student, and they provide financial resources. It is heartbreaking. So some of the things I hear from my students, often they are stuck not having their basic needs met. It was heartbreaking. A student told me she didn't have a coat during wintertime. I had another student just this year who was missing $200 just to graduate. So we need to put money and resources to those that just don't have it. Okay, that's all I have to say. Thank y'all for your time.
Thank you very much, Jessica. If you get a chance to read all the comments, you'll see there's a lot of resonance with your remarks. So now we turn to our very engaged audience for their questions, and I've been looking them over, and I think since the Roman telescope is going to be launched in just a couple of days, let's start there with questions about the telescope. And I've asked Rachael to, some of the questions are quite technical. So I said, Rachael, can you just sort of summarize the things that you think are the most important? And my favorite sort of semi-technical question is, can you compare what the Rubin telescope will do, which is ground-based, it's in Chile, it's operating now, Vera Rubin telescope, with the Nancy Roman telescope. So can we start there, Rachael?
Yeah, absolutely. So I did answer the question in the chat to the person who posed it. I'm not sure if everyone can see it. But yeah, so Rubin is the Vera Rubin Observatory is a ground-based observatory in Chile. It's on a mountain near a bunch of other observational sites. It is an 8-meter telescope, and it has a much larger camera. I believe it's a 3 gigapixel camera. And you can make something that big on the ground because it's on the ground, right? Because it's on Earth, and you can get to it and fix it. Things can be much bigger and heavier. So it has a much larger field of view every time it takes a picture. It works in the optical or the visible, which is the light we see with our eyes, whereas Roman is going to work in the near infrared. There's advantages to working in the near infrared because we can see to further distances, further redshifts, and it's beneficial for some of the science cases that we want to do because of some of the detailed properties of the objects. Now, even though Rubin has a bigger field of view and more pixels on its camera, it's always fundamentally limited by the atmosphere. There's actually a really beautiful quote from Nancy Grace Roman that looking through the atmosphere in many ways is like taking a really old piece of glass, foggy glass that was probably handmade, and trying to look through it to see things in your life. So the atmosphere actually blurs the stars considerably. And so the Rubin telescope will only able to resolve or to sort of magnify or get the details limited to what the atmosphere allows it to do. And there's some other physics with how telescopes, ground-based telescopes are designed and the enclosures that we don't need to get into, but it can only do about 1 arc second. So there's another lovely question about, what magnification the Roman telescope has. So if you take a fairly thin ring, so if you take your thumb and you put it at arm's length, that's about 1/2 degree on the sky. That's about the size of the full moon. And so from 1/2 degree, you can kind of figure out what your eye can actually resolve. So a ring is about at arm's length is about the size of what HST turns into 2K by 2K pixels on the sky. So what Roman sees on the sky is your thumb at arm's length, but we actually visualize it on 300 megapixels. And the size of those pixels are fractions of an arc second. So the resolution is very high. So those are the kinds of comparisons. Rubin is doing a movie of the sky. So it's covering this huge area and revisiting it over time, whereas Roman is doing much more specialized data collects. Some of the science cases are very similar, but we're going to answer them in very different ways because of our capabilities. And there's a huge effort of astronomers trying to combine them. That unfortunately, the NSF and NASA have a deep chasm between them when it comes to sharing funding for various reasons that France probably knows a lot about. But we're working very hard to figure those out. One of the hardest ones actually is that Rubin is using Google cloud infrastructure and we're using Amazon cloud infrastructure, and things get very complicated. But we're trying to work together with our shared science goals.
Yeah, great. Yeah, you explained that so well. Thank you. And yeah, there are people. One is Joya Rao. I don't know if you all know her, young astronomer who works for Renaissance Philanthropy. And she has just come out in the last few days with a brilliant paper about the importance of putting the Rubin and the Roman and the Euclid European satellite data all together. And as you said, Rachael, they're all what we call heterogeneous databases. They're very different databases. It's a very hard infrastructure project to do. But we're in the philanthropy community, astrophysics community, we're working with her and the team in Renaissance Philanthropy to see if this dream can come true, that everybody out there, like the folks that are watching tonight that are interested, can eventually, and we hope it's not too far in the future, can access a unified database and get a hold of all the data and ask whatever questions they want to ask. So I think this is a whole new thing. It kind of is interesting to me that the first women in science were called computers, because they were doing computational types of things, and Meg showed a wonderful picture of them at Harvard. And now they are returning to that using AI techniques. And again, women scientists are using, becoming computer scientists along with their astronomy backgrounds in order to merge these databases and make new discoveries. So let's see, what other questions do we have here? So there are questions for the ASP, and maybe, Linda or Teresa, you want to answer those about how people can engage better with the ASP and be involved in their programming and all?
Yeah, I'll let Teresa talk about the programming, but the one thing I'll say, just to be somewhat self-serving or whatever, Nancy cared a lot about contributing to the ASP and our mission. So just saying. I think Chanel put a link up in case you want to donate. These are tough times for all nonprofits, and especially in education. So just saying. So Teresa, if they want to get involved and with some of the education programs and take some of the online courses, what do they do?
Thanks, Linda. Yeah, donating is great if you can. And we understand that some people can and some people can't, but we love having all of you in participation. We have a program called Learn at ASP, which is in the chat. It's learn.astrosociety.org, and it has courses that you can take. They're very a small fee. I think it's $40 for the average one. Some of them are free, and we really encourage you to join. If you're interested in some of the issues that we brought up today, there is a course that you could take called Confidence and Curiosity that is totally free. It's a self-paced workshop. These are online programs that you can take. Also, the Night Sky Network has a lot of resources for outreach and engagement of the public. We have monthly webinars that you can see on YouTube. That's free as well. We have so many programs. I'm trying to think of how I can say them all. AstroBeat is a new program that our director, Hakeem Oluche, is doing, and he is doing a fantastic job on that. Just keep an eye on our website. We have great programs, and of course, you can still join our conference, which is meeting tomorrow and the next day. So, and all of the recordings will be available afterwards. If anyone, I saw Chanel, you undid your camera. So if you have other things you would like to share, please do.
That was perfect, Teresa. I think I have a question for Rachael. I know she answered it in the chat or in the Q&A, but it has come up. We had some high school students join us earlier. I was going to say it's past their bedtime. It's past my bedtime, probably not theirs. But nevertheless, since this will be recorded and will be archived on YouTube, what Ruben and, of course, Roman facilitate and enable, because of the overwhelming data that will come from these observatories every night, it facilitates a whole class of citizen science, or participatory science, as it's now referred to as. Can you speak a little bit about that and how high school teachers, students, the general public can get involved in actually doing fundamental, basic astronomical research?
Absolutely. So I'm actually on a team that's building the tools that we will use to connect Roman data to the Zooniverse. So the Zooniverse is a citizen science platform that works with all sciences, but in particular, a very large number of astronomical projects. It was founded by the SDSS collaboration, and is the PI is Chris Lintott at the University of Oxford. So the Rubin Galaxy Zoo, someone noted in the chat, oh, William Keel. Okay, I know who that is. Mentioned in the chat, Rubin Galaxy Zoo is already up and running. Euclid Galaxy Zoo is up and running. And we are working on the Roman Galaxy Zoo as we speak with Karen Masters at Haverford College. And so that will be classifying galaxies, millions and millions and millions of galaxies. There are also programs tracing spiral arms and doing all sorts of different types of things that help us build large samples with the types of projects that actually teaching computers is really, really hard to do. And our human eyes are just much better at it. We're also using those trainings to build machine learning tools so that we can move our citizen scientists to the front lines and doing the most interesting research we possibly can. So when it gets boring, we're happy to let the computers do it. So we're hoping that there will be lots more citizen science projects because we are getting the infrastructure set up and making it as easy as dragging some plots into a directory and sending it to the Zooniverse. And anyone is welcome to participate through the Zooniverse at any time. And we hope to see you there. I should be online with the Roman projects soon. There's a note in the comment about art projects. And yes, the Institute, the Space Telescope Science Institute, we have a number of partnerships with local artists in the Baltimore area who do inspired art based on what the telescopes are doing. And we have a show every year. But yes, there will be so much going on. Our artists in residence are cosmic artists in residence who actually make the beautiful images that come out have been playing with 300 megapixels. They need special equipment and software to actually do it. And I will be one of the people looking at those images one of the scientists looking at those images for the first time in a couple months. So that will all go live as well. So
Great.
we hope to see you participating.
Thank you. Yeah, we just got the notice that there's just a couple more minutes left. So I want to give all of our presenters an opportunity to say one thing to our wonderful audience. And you've been so engaged, audience. We really appreciate you. I'll start with Jessica, but it has to be a lightning round.
Yes, I've seen some comments about people wanting this to be more about Nancy Grace Roman and our personal contribution to it. And I would say that our collective contribution within the field is the thing that we've tried to highlight. So maybe if that didn't reach out, and I challenge everyone that as we continue to wait and we think it's just a social thing, there are people that are suffering in silence. And so just remember that when we're not being brave, when we're not stepping up, there are people that are still silently suffering. Thank y'all again for this opportunity.
Thank you, Jessica. Linda.
Yeah, I would just say that, just repeat what I said earlier, that, we stand on her shoulders, and then always remember that other people are going to be standing on our shoulders, whether you're a woman, whether you're a person of color, whether you're a man, it doesn't matter. You're a role model to somebody. And one of the things we're celebrating here is how Nancy Grace Roman has been a role model in science, in education, and as a human being.
That's a big thought. Thank you, Linda. Meg.
Thanks, France. Thanks for chairing the panel too. It's been wonderful talking with all of you. So many things to say, but I'll just end with a thought about Nancy Grace Roman. There's a wonderful interview with her Dave Dworkin did at the American Institute of Physics, which I recommend everybody. I saw that someone put it in the chat, the link, so you can find it there. And she was really an inspiration to me and to many other people. And it just makes me so happy that these two women, Rubin and Roman, are going to be our premier telescopes for the next decade. That's pretty super. So that's a thought I'm going to end with.
Great. Wonderful thought. And Rachel, we wish you the very best. You got to get that telescope up into space. So you're on your way. You want to close out our conversation here?
Yeah, I just want to invite, along the lines that we've talked about participating in science, I just want to invite everyone on the call to join in, whether that's through Zooniverse, through watching the live streams, through jumping on the Nexus and playing with data, or just promoting the science that's coming out through your networks. We do this for the community and and all of us that work at NASA. We do this for you guys and for the public, to inspire you, to give you creativity, and to see what you do with the things that we put out in the world. So please keep participating in all the ways that you can.
Great. Thank you. Thank you, everybody. This has been terrific. Thank you, Astronomical Society of the Pacific.
Thank you, France. Thank you to our panelists. And just before we bid adieu, we want to do one last piece of current slide. And after tonight, how has your understanding of Nancy Grace Roman changed? I discovered her story for the first time. I learned considerably more about her. I gained a deeper or different understanding of her legacy. I was already familiar with her story. We're nerds. We like to see if we move the needle.
Well, looks like a lot of people gained a deeper understanding of Nancy Grace Roman. And really, that's what we wanted to do, was open the dialogue about this amazing telescope and this amazing woman that has made so many inroads for women in astronomy and for people in the world. Thank you so much for joining us.
So for this one, it is in one word or short phrase, what should Nancy Grace Roman be remembered for? So you heard a lot of wonderful stories, anecdotes, relationships. If you were now to put this together and synthesize, what would you say? I love these verbs coming out. If you like these images, we're going to share them on social, so you'll be able to get them there as part of Astronomy at 250, this 3-day conference that the Astro Society is holding. This is part of our engagement. We're trying to measure, so it even has a science component to it to see how well we can do this in an online setting. So you can also see those images on social media. Okay, last one. Did this conversation leave you with a new question you didn't have when it began? Right? Hallmark of science is that you answer one and 10 more present themselves. Is that true tonight?
Thank you so much, Chanel, for putting these pieces together. And as we're finishing up our Stream Alive and engagement, I want to thank you all for being here. And thank you, panelists. You did an amazing job. It was great to hear so many different perspectives on Nancy Grace Roman. And she's such a powerful legacy and such a celebration of her life. So thank you all for joining us. For all of you on YouTube, thank you again for everyone here. And thank you for joining the Astro Society tonight. We will see you hopefully next month for the Night Sky Network on YouTube.
Keep looking up.
Very true. Take care.
You guys done?
Almost.
Yay, that was wonderful.
Thanks, you guys. That was a great deal of fun.
Yeah, it really
Thank
was.
you.
And thank you for the audience was very engaged.